I'm so glad to be here, and I'm the engineer from Red Hat and also the RISC-V ambassador from RISC-V Foundation. And today I will give you a report about Linux distribution and why we need it, and how to practice it on x86 computer. So next slide. Okay, so that's the agenda, and I will go through it, and I will get help from Supei to get a slide change because I'm using the Linux computer. So yeah, next slide, please. This is so right now I will introduce what is the Linux distribution. People will make very interesting about Linux running on RISC-V, right? So most of people cared about if the Linux kernel supported, right? But actually, most importantly, if you of course, if you run a Linux kernel on a RISC-V, that would be great. But if you don't have the distribution, just run the kernel on it, it doesn't mean too much because you don't have any application on it, right? So Linux distribution is very important. Next slide. So you can see the Linux distribution everywhere, from the end device like the embed system, OpenEmbed, Yocto, build root, and even on Android system. So, and then you can see the OpenWRT on gateway or edge compute. The feature of the common feature from on this area is they all compiled by cross compilation. And then most of people learn Linux from PC or the server. So on a cloud platform, you can see a lot of different Linux distribution running on a cloud and PC. So you can see next slide, please. And even on the supercomputer, right now, all the supercomputer running Linux. Several years ago, you can see, maybe there's a 10% computer still running Unix or Windows. But right now, all the supercomputer run Linux, and more than 20% of this supercomputer is running real CentOS. So that means Red Hat side distribution is very popular, not just on a normal server, but also on a supercomputer RAM. That's the latest information from top 500. So you can see the importance of the Linux distribution. Next slide, please. So what is the Linux distribution? Linux kernel is the core software running on hardware, but you still need a lot of application. But how to manage it? This application package or all the different application. If you just recompile it and install, just like the normal developer, it's very hard for all the people. So you need a package management system to do it. So right now, most popular package management system is RPM system, Debian system, and DEB, Debian system, and OPKG, which is using IPK package. So these three systems are more is very popular. They distribute the binary directly. Also, there are some distribution manage the software by recompiling the software download from the website and recompile it directly on the host, like Gen 2. So this is the Linux distribution, which can help you to manage all applications, all application and the Bing binary on your system. Next, please. Next slide. So let's talking about Linux distribution. The status of a Linux distribution on RISC-V. First of all, I will introduce Fedora. Not because I'm come from Red Hat, but also but because I'm the Fedora. For now, the reality is for now the Fedora distribution is the most complete and the most useful distribution on RISC-V. So this distribution, the image of this distribution is bootable. You can just download it and get a firmware from the image, and then flash into SD card to boot up the real hardware. And also you can use this firmware to boot up QEMU directly. So it's bootable and managed by this system, managed by DNF and RPM package, as you may know. And in my previous presentation, I introduced about Koji. I would make a short introduction later. So right now for Fedora, we are building Fedora 33 also called rootfs in Koji system. And if you want to download all the package, or you want to update update your RISC-V, update your Fedora system on RISC-V, you can use the repository I'm share with you in this slide. So so I can say if you install a Fedora on RISC-V, and you will just like it will just like use a x86 computer right now. Next slide, please. So this is the Koji build system for Fedora. And when you build a package, different people have a different environment to build the same package. If they just upload it to the repo, it will make a lot of trouble, because different environment make the result linked to different library. So if the library difference and some binary cannot run on all the computer, so we need a unified build environment and build system for all the developer. Koji solve this problem. What you can do, just you update the package to Koji, and Koji will help you to build a system. Will help you to will help you to handle this package to different builder, and all the builders share the same repo, same build system, and help you to have a unified build system for all the package, and then they will make a unified binary for all the system. So so this build system will be very important for all the distribution, and I think some other distribution have their own build system, like SUSE has open build system, and Debian has their own system. They all solve the same problem, is they need the unified build environment. Right now, the Koji system running in US, and we also building a new Koji system, try to help the original build Koji system in China called OE packages. We are working on it. We will release this system in 2 or 3 months. Thank you. Next one. Next slide, please. Okay, thank you. It's not just for RISC-V, we not just for we don't just have Fedora. We also have some other Linux distribution. We are all happy to see different distribution can running on RISC-V. So you can use Gen 2 and Arch Linux. So there are some developer from German and also from Russia. They are working on Gen 2, and also you can see one Chinese developer working on that. They already made Gen 2 running on Unleash, and they just told me they're happy to use to make Gen 2 running on it, and you can download the Gen 2 Stage 3 imaging online and try it on. And maybe not too much people know Arch already running on RISC-V, but right now because we don't have a good firmware, so this distribution only can running from QEMU user mode. I will introduce it later. So these are two very important distribution. So we're happy to see that. Next slide, please. Except the normal Linux distribution, we also have some embedded Linux running on RISC-V, like OpenWRT, build root, Yocto Open Embed. You can boot it up. They can put it up by BBL or U-boot, and they are using they are building it. The packaging management is in the build time in the recipe or map file, and also can install the like OpenWRT. You can install a package by OPKG Linux package manager. And but the same common feature is they are using cross compilation. All these distribution are in maintenance, so we are happy also, you know, the embedded system can run on it. Next slide, please. And so after I introduce some Linux distribution, we also need to care about RISC-V firmware, the firmware which running on RISC-V. So good news is we already have used Open.SBI running on it, and OpenSBI plus U-boot is the standard boot flow for Fedora right now. But if we have Grub and UEFI, we may can switch to the more enterprise and PC-like firmware later. But for Grub 2, we already have some package upstream, and maybe we can use that. But for now, we have some trouble. We have some problem on UEFI, so we still cannot use Grub to boot the Linux for now. But we can do this later very soon. So next slide, please. So so right now, I will give you some good news, good progress of RISC-V firmware. After the hard work and after the a lot of hard work and by HPE and some other engineer, some UEFI maintainer, we already upstream all the patch for RISC-V to for UEFI. So right now you can use the the master branch UEFI to boot up QEMU and the real hardware Sci-Fi Unleash. So it's very soon we can use UEFI Grub to boot up the Linux distribution. Thank you very much for the hard work from HPE engineer from Taiwan, and also thank you for the maintainer like Leif, Leif from Nuvers. Thank you very much. And next slide, please. So we have a lot of different distribution, and the firmware can running on RISC-V. That means the software ecosystem for RISC-V is growing up very faster, and the state of that is very good. But why it is still a little bit slow? I feel it is a little bit slow because we need more chip. We need more silicon and IP for RISC-V. So we need your help to, if you making the RISC-V chip, you are making the IP, RISC-V IP, please contact with us and let us know you have a new hardware. We are very happy. We will be very happy to help you run Fedora or some other distribution running on RISC-V. For example, right now we are helping RIOS, RIOS Lab in China to make Chrome OS running on their new platform. There is event happened in Shenzhen right now. Introduce this status. We are helping them to putting Chrome OS on it. So once you have a hardware, once you have some idea, let us know. We can organize it. And yes, please, next slide. Thank you. Yeah, so I already introduced some distribution for that. So how we can try this distribution very easy. So people may say, okay, we can use QEMU, we can use the new real hardware. But if you don't have real hardware, if you have some trouble to recompile the firmware, so you can try the QEMU user mode. It's not a new technology, but normally people just use a QEMU sys RISC-V 64, this kind of binary. But you also can use the user mode to try it on x86 system. Next slide, please. So if you want to try this on the new x86 system, you can enable. You need to enable B format on your system. I have tried it on Fedora 31 and 32, and you just need a very simple step. Just install QEMU user static. Please be careful. Let's just you need to install user static to run user mode. But you also can compile the upstream QEMU. But in the configuration, you need a static in your configuration, and I have tried that and very successfully. And so you need to install this software on Fedora. Next one, please. Next slide. And then you need to enable the B format support in your system on Fedora. And you just need a command to enable that. And then you can verify the B format support. If you can see QEMU RISC-V is in the list by this commander, that means you already enabled it. You can go on the procedure. Next slide, please. And then you need to prepare the Linux distro rootfs. For example, we can use Fedora, imagine, but I also tried the Debian Gen 2 and Debian Gen 2. These two distribution, they are all can boot by the user mode. You can get a Fedora imagine by Fedora project and also from the code directly. I already shared information in a previous presentation, but if you have any trouble, you can contact with me, and I will show you the slide I have used before. So you can mount this modeless imaging on some directory. Maybe, for example, I molded on Fedora rootfs. So we can do the next step. Please, next slide. And then you can finally try the user mode. The command line is very simple. Just systemd and spawned -d and the directory you just molded. And some distribution cannot use -b because the systemd is incomplete. You can get rid of the b and just use the -d to enable to start the system. You will get into the RISC-V rootfs and try it on. So I already tried it and very successful, and hope you can enjoying this practice. Next slide, please. Next slide, please. So thank you very much for listening, and thank you for all the people who helping me to finish this slide. And I can take some question if we have time now. Thank you very much. Any question?
もういいから喋っちゃって、ここで。あ、こっち側でね。Okay. どうしたんだっけ? Sorry, I mean, I wasn't able to, let's see. Okay. Okay. So, there's some questions. Okay, so let me just actually look it up because it's in the. Okay, first of all, one question. Are you listen? Am I okay? So one question is, well, really, the most important question is, how is the support of Linux distro on RISC-V? Can we, for instance, boot RISC-V machine with Linux distro out of box, or what is the status?
Okay, so for now, Fedora is the most lead distribution for RISC-V, and some other distribution also in under development status. And we almost can boot up Fedora on QEMU and Unleash right now. Just need to do some freshmen, and the problem is the final step is we need to install Fedora or some distribution by a USB storage and some disks. That's the final step, but we cannot do that right now. We cannot really install a Fedora or some distribution out of box, because we still need some standards for PC for boot up procedure. That's the things we are working on. There's a group in RISC-V Foundation called Unix platform specification. One of my colleagues, Al Stone, is the chairman of this group. They are working on they are working on a specification, and maybe we can finish it in 1 or 2 years to make Fedora running on platform out of box, just like x86 in ARCT4 in a coming year, maybe. Thank you. Do I answer the question?
Yes. So I have like one more question. This is the last question because we are running out of time. And like most interesting for us is the reason that you are using native compiler instead of cross compiler in your development. This is the most interesting things that I heard.
Yes.
So please explain why that is necessary.
Okay, because we are facing the ecosystem, not just the Linux kernel. If you just want a very simple rootfs and the kernel on a RISC-V, you can use the cross compile, no problem. But if you want to run thousands of different software on a platform, you need to modify thousands of different makefile, and you need to familiar with this build system, not just makefile, but also maybe Ninja, Mason, and some other different build system, right? So it's a huge war for different architecture. If you can do the native compile, it will save a lot of time for making this modification. You can just running the build on the system which already installed Fedora or some distribution, and very easy to compile it. We also actually, it's come from my experience to bootstrap another architecture, not just x86 or ARM in RISC-V. We are trying to bootstrap RISC-V 32. I guess you are also very interested about that. We are trying to bootstrap Fedora on 32-bit system. And this procedure, when we do that, we really realize cross compile is not real. It's useless on this on distribution. We really need native compile to save our time, to make the system, to make the whole build system unified, just like the Koji system we are using. It's a unified system. If we cannot do that, we cannot do the native compile. You will make the software just like the pieces, and you cannot put everything together. I hope I answered the question.
Yes, you did. Thank you.
Thank you. Thank you very much.